We can now investigate the ocean in incredibly methodical, scientific, and non-invasive ways, thanks to today's technologies. Our ability to view the ocean ecosystem and its resident organisms is beginning to catch up with our imaginations, improving our awareness and appreciation of this still mostly uncharted region. Thanks to ongoing scientific and technical developments, here are the 10 things you didn't know about the ocean technology. By the way, make sure to click that subscribe button to stay up to date with all our engaging videos, and use that trigger finger by smashing that like button. Now let's get into it.
To thank you for watching this video, we're offering you an absolutely free training webinar. Do you want to learn the secret of improving all aspects of your life and unlocking what you're really capable of? The legendary Bob Proctor spent over 57 years learning this one thing and is hosting a free webinar where he reveals what he's learned and what actually works. He'll teach you the law of compensation, a secret only the mega wealthy know of but not taught in our educational system. And the impression of increase, the law of laws that will increase areas in all aspects of your life, whether it be in health, relationships, or wealth. Right now, the first 200 people to use the link below will get access to this free webinar. Now, let's get back to the video.
Number 1. Acoustic Doppler Current Profiler. An acoustic Doppler current profiler, or ADCP, is a device that measures the speed and direction of currents in the water column using sound waves. Understanding how ocean water travels offers crucial information about the ocean's biological, chemical, and physical features. The Doppler effect is used by the ADCP, which sends out pings of sound in the form of a series of constant, quick pulses that ricochet off particles suspended in moving water and return to the instrument. Waves with a higher frequency or pitch are returned by particles traveling towards the instrument, whereas waves with a lower frequency or pitch are returned by particles going away. The difference in frequency between the sound waves the profiler sends out and the sound waves it receives can be used to compute how fast a particle and the water surrounding it are moving, because the particles move at the same speed as the water that carries them. The system keeps track of when each ping is returned. Because pings that go further, lower, return later, this translates to current data at different depths. Number 2. CTD. The acronym CTD stands for Conductivity, Temperature, and Depth, and refers to a collection of electronic sensors that monitor how the conductivity and temperature of water change with depth. The CTD is a vital tool in all aspects of oceanography, providing vital information about the water column's physical, chemical, and even biological properties. A CTD is a collection of tiny probes that can be deployed separately or integrated into a number of observing platforms, including remotely operated vehicles, gliders, and stationary observing buoys. The CTD is frequently linked to a bigger metal water sampling array known as a rosette that is lowered into the water via cable on exploration vessels. Multiple water sampling bottles, also known as Niskin bottles, are frequently linked to the rosette. When the rosette is deployed, these bottles open and can be prompted to close, collecting water samples at preset depths for analysis later. Number 3. Drifters. The oceans of the planet are continually moving. Ocean currents follow complex patterns and are influenced by a variety of factors. There is primary land masses, the bathymetry, bottom topography of the ocean, the Earth's rotation, and atmospheric changes throughout the world all influence the speed and direction of water on our planet. Scientists are beginning to understand the complexities of global ocean currents and, as a result, the various systems that they influence, thanks to devices known as drifters. Drifters now supply researchers with real-time information about ocean circulation pattern, thanks to technological advancements. Scientists will be able to use the data collected from these sensors to create models of climate and weather patterns, like El Niño and storms, as well as predict where contaminants like oil or sewage will end up if dumped or inadvertently spilt into the water. Number 4. Environmental DNA, eDNA. The genetic material shed by organisms in the water column is known as environmental DNA, eDNA. Scientists can use eDNA to uncover new discoveries about marine life by collecting samples of mucus, excrement, or tissue particles. Water sampling instruments such as a Niskin bottle, which can be attached to a CTD rosette, or remotely driven vehicle are used by scientists to sample water at a place. The latitude and longitude, depth, and filter material of the samples, as well as the salinity and temperature of the water collected, are all labeled. After that, the eDNA is isolated from the water using a cellulose nitrate membrane filter and subjected to additional cleaning procedures. The DNA samples are then either frozen or maintained in a buffer, which is an aqueous solution and prevents sample degradation while still making DNA soluble, dissolvable. This allows scientists to preserve DNA for several years, which is useful when they come across a new species and need to revisit samples. Number 5. Magnometer. A magnometer is a device that detects changes in the Earth's magnetic field. It can be used to survey cultural heritage sites such as ship and aircraft wrecks, as well as characterize geological features on the sea floor in ocean exploration. The magnometer is usually towed behind the research vessel using a tow line on an ocean exploration expedition, but it can also be put to an autonomous underwater vehicle, AUV, or an aerial drone. Although the sampling rate can be modified, the magnometer samples background magnetism at a rate of around 1 reading per second, or 1 hertz, unless the magnometer finds something ferrous, containing iron, such as a ship hull fragment, an anchor, or a basalt geological structure. This number is normally stable. On the magnetometer's display, this shows up as an unexpected change in magnetism or an anomaly. This technique can locate artifacts and even shipwrecks, whether they're visible above the seafloor or buried totally. Number 6. Geographic Information System, GIS. GIS is for Geographic Information System, and it's a computer-based theoretical framework for organizing and analyzing data connecting to positions on the Earth's surface. GIS can help us better understand the ocean by combining spatial data with tabular data, also known as attribute data. GIS provides a digital platform for viewing and analyzing layers of geographical information using maps and three-dimensional scenes, rather than just showing data in a spreadsheet. A GIS can effectively construct a simulated ocean within a computer with enough data. A computer with specialized software and spatial data are required to create a GIS. Vector-based and raster-based data are two of the most often utilized types of data in GIS. The locations of points, lines, and polygons in vector data are defined by X and Y coordinates, or areas. Points can represent city-states, lines can represent rivers and roads, and polygons can represent state boundaries in the United States.
To thank you for watching this video, we're offering you an absolutely free training webinar. Have you ever wondered how to end procrastination and self-sabotage so you can unleash your full potential to live the life you deserve? #1 best-selling author and high-performance coach Peter Sage is hosting a free webinar where he'll teach you how to increase your wealth with less time and struggle, and also how to hyper-boost your growth and success so you can finally break out of any rut you find yourself in. Right now, Peter and his team are offering a free $100 gift to anyone who doesn't find his webinar as the best use of their time within the last 5 years. Now, let's get back to the video.
Number 7. Structure from motion photogrammetry. Motion creates structure, SFM. Photogrammetry is a technique that uses two-dimensional photographs to approximate a three-dimensional structure. To create the three-dimensional 3D model and other products like photomosaic maps, photographs are stitched together using photogrammetry software. It's because a useful tool for quickly capturing underwater archaeological sites, as well as characterizing seafloor phenomena like coral reefs. A remotely operated vehicle, ROVE, or a team of divers are used to take photographs in photogrammetry. A camera follows a predetermined path around the construction site, taking hundreds of thousands of still photos from the top, sides, and inside. It's critical that the images overlap so that every inch of the site is captured from multiple perspectives. By capturing video footage and producing still photographs, video footage can also be used for photogrammetry. Number 8. Environmental satellites. NOAA satellites orbiting high above the Earth's surface collect data in real time to monitor and understand our changing world. Environmental satellites are satellites that detect and observe various characteristics and properties of the Earth's atmosphere, land surface, and ocean. Satellites can be used to investigate ocean bathymetry, sea surface temperature, ocean color, coral reefs, ice cover, and other topics. The most common orbits for environmental satellites, geostationary or polar orbiting. Geostationary satellites orbit the Earth at a speed that corresponds to the rotation of the planet, allowing them to keep a constant eye on a specific area of the surface. Every day, polar orbiting satellites pass over the same spot on the Earth. Polar orbiting means the sun-synchronous environment satellites orbit the Earth from north to south, passing over the north and south poles on each orbit. Number 9. Sonar. Sonar, or sound navigation and ranging, is a method for exploring the ocean using sound waves. Sonar is largely used by scientists to create nautical charts, discover underwater navigational hazards, search for and identify objects on the water column and on the sea floor, such as shipwrecks, and map the seafloor. Because sound waves travel deeper in the water than radar and light waves, sonar is utilized in oceanography. The sonar system is made up of transducers, which are physical sound sensors. Scientists can utilize a single transducer or a transducer array, which is a collection of them. A remotely driven vehicle, an autonomous underwater vehicle, a ship, or a platform like a towfish or glider can all have an array attached to them. Active and passive sonar are the two forms of sonar. Number 10. Multi-beam sonar. A multi-beam sonar system is an active sonar system that maps the seafloor and detects items in the water, column, or along the seafloor. The sonar's transducer array, which consists of several physical sensors, sends and receives sound pulses that map the bottom or detect other objects. A multi-beam array is often fixed to the ship's hull. A multi-beam sonar, unlike single-beam sonar, which maps the seafloor with just one transducer, sends out many simultaneous sonar beams, or sound waves, in a fan-shaped pattern. This includes the area directly beneath the ship as well as to each side. Seafloor depth and backscatter are two forms of data collected by multi-beam. The time it takes for the sound to leave the array, hit the seafloor, and return to the array is used to calculate the seafloor depth, or bathymetry. On board the ship, scientists analyze the speed of sound in the water they're surveying in order to convert the two-way travel time from the ship to the sea surface and back into a depth measurement. The strength of the sound echo that bounces back to the multi-beam array is measured as backscatter. So, what can you say about the 10 things you didn't know about ocean technology? Let us know in the comments section below. And hey, if you enjoyed the video, don't forget to like and subscribe to our channel so we continue giving you the best contents. Thanks for watching. See you in the next video.